For example, to start with the quadratic equation, say for example, I take x squared plus 4x minus 4 equal to 0. This is clearly a quadratic equation, but the factorization method may not be helpful out here. Say for example, I just multiply with the factorization method with 1 and 4, I get 4 to be the value for which the possible factors need to be identified. So let me use the possible factors 2 times of 2, which gives 4, and therefore the factorization is possible by taking 2 plus 2, which stands for coefficient of x, which is 4. So let's try to use the factorization method in splitting the middle term according to the factors of 4. So this can be further simplified to be split with the middle term 4x, which can be written as 2x plus 2x minus 4 equal to 0. So with all the possible factors identified here, this seems to work well. But the factorization method is not a success out here. The reason being that if I have, the rule says I need to have the even number of plus signs and even number of odd minus signs in the entire quadratic equation after splitting the middle term. But when I see the plus signs 1, 2, 3 plus signs and 1 minus sign is an odd case out there. So there are 3 plus signs and 1 minus sign in case of this quadratic equation. Therefore, factorization is not possible. Factorization method fails. So in case of such quadratic equations, factorization method may not be a suitable choice. Therefore, for those kind of equations, we try to modify a more different method called the complete square method. A complete square method can be applied for such quadratic equations, and hence let's see how the complete square method can be used in solving of a given quadratic equation. Now before we start with the complete square method, there are many steps which we need to follow in finding out the solutions using the complete square method. So let's take an example problem and examine each of the steps on how the different steps need to be proceeded in finally solving to find the solutions of the given quadratic equation by complete square method. So initially, let me take a quadratic equation, say for example 5x squared minus 6x minus 2 equal to 0. As I clearly identify here that my coefficient of x squared is 5, coefficient of x is minus 6, and the constant term is minus 2. Now this I would like to solve using the complete square method. And hence what I would do is, the first step is I divide the whole equation by 5. The entire quadratic equation is divided by 5. The reason being that the step 1 says that I always need to make the coefficient of x squared to be 1. Divide by 5 to make the coefficient of x squared equal to 1 always. So any problem given out there, the first step or the first destination is to make the coefficient of x squared equal to 1. Therefore, because I have the coefficient of x squared is 5, I can make that equal to 1 until and unless I divide with 5, I don't get the coefficient of x squared equal to 1. Therefore, immediately I divide by 5, simply to make the coefficient of x squared equal to 1, the rule 1. This says the rule 1. So let's divide and see what finally I get. Equal to 0 by 5. Then this reduces to x squared minus 6 over 5 of x minus 2 over 5 equal to 0 is what I get. And now my destination of reaching the coefficient of x squared equal to 1 is finally reached out here. Now with this coefficient of x squared being 1, let's try to see how I can make this a complete square. As the method itself says complete square, my destination out here is to make this in the form of a square. Therefore, let's see how I can convert this into a perfect square or a complete square. Method is what it is about. So when I clearly see this is in the form of a square, and I can convert the formula a minus b whole square as a square minus 2ab plus b square. Therefore, in order to get a minus b whole square, I need to just see that this reduces to the form a square minus 2ab plus b square is the target out there. So therefore, I have a square minus 6 I can write as 2 times of 3 by 5 into x minus 2 by 5 equal to 0. So the reason why I split this 6 into 2 times of 3 is because I want to reduce this into the form a square minus 2ab, and b square is the term missing out there. Therefore, this being b, I add and subtract the b square term so that I get a complete square. So let's see how we can do that. So a square minus 2ab written in order, and b square is not available here. So equally I add this b square term and subtract the b square term equally so that the whole equation doesn't get disturbed. So adding and subtracting the b square term is strictly because I want to reduce this into a perfect square, where the formula says a square minus 2ab plus b square is a minus b whole square. We all know that formula. So if this is reduced to the form a minus b whole square minus, this can be simplified with 9 by 25, because 3 square is 9 by 5 square is 25, minus 2 over 5 equals 0 is how we obtain the perfect square. So now this is where the perfect square is obtained. Now next step is about taking LCM and finally simplifying for the x and y. For x, the value of x. So let's see how we can continue further from here by taking LCM. Now let's take LCM on to these two constant terms so that I get x minus 3 over 5 whole square minus 25 being the LCM reduces to 1 times of 9 is minus 9, and this would be plus because I have taken minus common together from these two terms outside. So I get plus inside the bracket, and then 5 times of 5 is 25, and then 5 times of 2 is 10 is how I do the LCM of the two given numbers. Now then this reduces to an equation where the constant is taken to the right. Therefore, from here this implies x minus 3 over 5 whole square will be equal to 10 plus 9, 19 over 25. Now this is further simplified by taking square to the right side, which reduces as a root. So when x minus 3 by 5 whole square is equal to 19 by 25, then that implies x minus 3 over 5 is equals to root 19 over 25. Of course, I get plus or minus out here, because when x squared is y, x is plus or minus root y. Remember, x squared equal to y implies x equals plus or minus root y is a very important formula out here. When x squared is y, x is not root y, but it is plus or minus root y. Even the minus sign holds true along with the plus sign of root y. Therefore, I get plus or minus root 19 over 25. Therefore, simplifying this, I get this as x minus 3 over 5 is equal to plus or minus root 19 by root 25, which is 5. This constant on the left is again taken to the right with two values, where I get one of them with plus and one of them with minus. X minus 3 over 5 is root 19 over 5, and then again x minus 3 over 5 is minus root 19 over 5 is how I get one plus and one minus. Thus, one of the plus giving me one solution of x and one of the minus giving me two solutions, the second solution of x. Therefore, I'll get two solutions for a quadratic equation with degree equal to 2 at most. two solutions. Now in this case, x would be root 19 over 5 plus 3 by 5, which comes out to be 3 plus root 19 over 5 is one of the solution, and then this reduces to x equals, this brought here will give me minus root 19 over 5 plus 3 over 5, which on LCM gives me the final answer as 3 minus root 19 over 5. Therefore, I get two solutions for the given quadratic equation, this and this, to be the roots or the zeros or the solution of the given quadratic equation using complete square method. So this is how we do the complete square method. Now sometimes there are quadratic equations in the form, say for example 3x squared minus 5x plus 2 equal to 0. Then in case of such quadratic equations, the complete square method also can be used, but need to be identified with the exact formula of a square minus 2ab plus b square, or a square plus 2ab plus b square with the respective formulae. Now in case of this, let's randomly check on how the complete square form can be done. Now for example, I have this quadratic equation 3x squared minus 5x plus 2. Then the first step of using the complete square method is that I need to make the coefficient of x squared equal to 1. Therefore, I divide the whole equation with 3 so that I get x squared minus 5 over 3x plus 2 over 3 equals 0. This is how I get the quadratic equation reduced with coefficient of x squared equal to 1. But here, as I observe, this is in the form of a squared, but I don't have 2ab. There's no term 2 multiplied to this. Therefore, I need 2. So what do I need to do? In this case, what I do is I write in the form 2ab. I reduce this to 6 because I multiply with 2 and divide with 2, so that this becomes strictly in the form of a formula a squared minus 2ab. Whereas this, again on simplification, gives back the original term 5 over 3 of x. So cancelling 2 1s and 2 3s, again I get back 5 over 3 of x. And the reason why I multiply here is that I have the formula a minus b whole square equals a square minus 2ab plus b square. Now this being a square, I need 2ab, and hence the 2 is multiplied. It is essential and very much needed to multiply 2 and equally divide with 2. Plus 2ab is there, but again I need b square to make this a perfect square. So I just add b square and subtract b square as I have done in the previous problem. So adding of b square and subtracting of b square with the original term 2 by 3 undisturbed will make this to be a perfect square, is how we understand the perfect square method. So in this case, this reduces to x minus 5 over 6 of whole square, and then this reduces to minus 25 of 36 plus 2 over 3 equal to 0, and thus we proceed as we have done here. But the most important part of this method is to identify the coefficient of x squared and then reducing this to a complete square form, either by using the formula a minus b whole square or a plus b whole square, is a very important note for this method, the complete square method. Now the third method of solving the quadratic equations is the discriminant method. The two other methods we have seen were the factorization method and the complete square method. Now the discriminant method is the most powerful method because this doesn't have any restrictions. This method can be used for any quadratic equation irrespective of splitting in factors or making it a complete square. So this is identified as the most powerful method in solving the quadratic equations. And let's see how it is done. It is done with the use of a formula which we are going to see in discriminant method. Say I take the general quadratic equation or the standard quadratic equation ax squared plus bx plus c. if my quadratic equation is ax squared plus bx plus c equal to 0, with a not equal to 0 and a, b, c are all real numbers, then it has two roots. We all know that this quadratic equation with the degree 2 has at the most two roots, and the two roots are given by the formula x equals minus b plus or minus root of delta by 2a, where one of the root is with plus and one of the root is with minus. So when I take this split as plus and minus, I get x equals minus b plus root delta by 2a, and here one of them is minus root delta by 2a, where delta is b square minus 4ac and is called the discriminant. This value of delta is called discriminant, is how we identify the formulae of finding the solutions of any quadratic equation using the discriminant method. Now this has a very significant role to play in quadratic equations. This decides the nature of roots or the nature of solutions which you obtain, and we will see this in brief in the future sessions. But discriminant has a very important role to play in quadratic equations. The two of the roots given by this formula and this formula finally identified to be this. So let's see an example problem where this can be applied. This formula can be applied where the two solutions are obtained. Now let's take an example problem to study the discriminant method of finding the roots. So for example, I take a quadratic equation 2x squared minus 2 root 2 of x plus 1 equal to 0. Then I need to find the roots of this quadratic equation. Now if I compare this quadratic equation with the general form ax squared plus bx plus c, then I clearly identify that the value of a is 2 and the value of b is minus 2 root 2 and the value of c is 1, because ax squared plus bx plus c, where a is this, b is this, and c is this. Now to find the roots using the discriminant method, initially I need to find the discriminant delta. So as we know that the discriminant delta is given by the formula b squared minus 4ac, then I simply substitute the values of a, b, c in this equation and I get the value of delta. So first, finding the value of delta is very important in discriminant method. So let's find delta in the initial case of solving the given quadratic equation. So this, when substituted with a, b, c respectively, my b is minus 2 root 2 whole square minus 4 times a times c, which is 1, is how I substitute b squared minus 4ac. Now this, on multiplying twice, because this is square, I get 4 times, because 2 square is 4 and root 2 whole square is 2, because root x into root x is always x. This is very important to identify. Root x into root x is always x. Minus 4 times of 2, which is 8. And then finally I get this to be 8 minus 8, which is 0. Therefore the value of discriminant or delta is 0. Now let's come to the formula. We have seen the formula for discriminant method, which says that the roots of any quadratic equation in its general form is given by the formula x equals minus b plus or minus root delta by 2a, is the formula which we have taken in the previous session. Now let's try to substitute each of a, b and delta in this given formula and then find the values of x, which are the solutions of given quadratic equation. Now in this case, b is minus 2 root 2, so minus of b plus or minus root of delta by 2a is how I get when I substitute the two values. This This gives me 2 root 2 plus or minus 0 by 4, which is 2 root 2 by 4. So this is root 2 over 2, and therefore I get the values of x, which is root 2 over 2 can be written as root 2 over 2 can be written as root 2 whole square, because root x whole square is x. So x can be written as root x whole square, which is nothing but indirectly in this form, so that I can cancel one of the root 2. The reason I write 2 as root 2 whole square is I want to cancel this, which gives me x equals is the required solution. Why is the need to write this twice? Because if we get one root, that indicates that the roots are repeated. In case of this, since it has two roots, one of the root is obtained which is repeated again. So this example quadratic equation is said to have the repeated roots in the discriminant method. Is how we understand using of discriminant formula in finding the quadratic equation, where this is called the discriminant formula. This formula is called the discriminant formula for finding the quadratic equations using the delta, which is the discriminant. So now that we have seen all the three methods in finding the solution of a quadratic equation in their respective processes, now let's see the last method which we have seen, the discriminant method, continued with this, because the nature of roots which we were talking about is strictly something which depends on the discriminant delta. So initially, let me start with significance of delta. What is the use of delta in solving of the problems? What is its significance, or the main role is what is for the session. So to start with, the significance of delta is it decides nature of roots. So delta decides the nature of roots, because sometimes the roots are repeated and equal, sometimes there are two real and distinct roots, and sometimes there are no real roots but the complex and imaginary roots. So this delta decides under what circumstances the given quadratic equation has real and distinct roots, or two repeated real equal roots, or it has no real roots, is how we decide through strictly the value of delta. So let's see how it is possible. So firstly, if delta is greater than 0, then secondly, the possibility is delta equal to 0, and thirdly, the possibility is delta less than 0, delta being b square minus 4ac, as we all know. So if delta is greater than 0, then we say roots are real and distinct. We say the roots are real and distinct. If delta is 0, then we say that the roots are real and equal. So whenever we get the repeated roots, in that case, delta will always be equal to 0, as we have seen in the previous case where delta was 0, and hence we got two repeated roots, 1 by root 2 and 1 by root 2. Is the reason because delta was equal to 0. So in such cases of delta equal to 0, the roots are real and always equal, that is repeated roots. They will be repeated similar root. Now when delta is less than 0, no real roots. That is, we say that the roots are imaginary or complex. Roots are imaginary or complex, is how we understand the three different concepts of understanding delta. Now, when the roots are real and distinct, we understand that its graph. As we have seen the graphical concept of understanding the quadratic polynomial when we were discussing about polynomials, let's revisit that in understanding that a quadratic equation is nothing but gives the roots which are the x-intercepts of the given a real xy coordinate system. So in my quadratic equation, if I draw somewhere like this, then this is called a quadratic equation in the form y equals ax squared plus bx plus c is what we get as the general quadratic equation, y equals ax squared plus bx plus c. So in this quadratic equation, which is represented by a parabola, we have also seen that if a is greater than 0, it is upwards, and if a is less than 0, then the parabola is downwards. Is how we understood the concept, the graphical method of understanding the quadratic polynomial. Now, if we revisit that, we try to connect the nature of roots with the graphical concept of quadratic equations. As we see here, when I say the roots are real and distinct, the two real and distinct roots are given by x equal to minus b plus root of delta by 2a is one root, and x equal to minus b minus root delta by 2a is the other root, which I get out here. Is how we understand the concept. Now in this case, when the roots are real and equal, we say that the roots here are identified to be minus b by 2a and minus b by 2a. The two roots are equal and repeated is given by this formula. Next, when I say no real roots, then solution x does not exist in real plane. We get complex roots, but in real plane, solution x does not exist in real xy coordinate system, is how we understand through the root concept. Now, how do we connect this roots with the quadratic equation in the graphical method is also very important. As I see here, when I get two roots, this makes me understand in the graphical method that the roots are the x-intercepts of the quadratic equation. That is, these roots will decide the points or the values where the graph cuts x-axis. Therefore, for two roots, I identify the graph to be in the form of cutting twice. It cuts at 2 points, A and B. Point A is given by this and point B is given by this, or respectively, is how I understand with assuming that A is greater than 0, I get this in the form. Now how do you understand this in graphical method? I understand this as the graph which touches x-axis. Therefore, for repeated roots, for this being x and y axis, the graph touches for the repeated roots. And for the non-real roots, the graph doesn't cross x-axis. It escapes the x-axis but cuts y-axis, but it will be hanging in air, but it doesn't cross x-axis. It goes on the top, but it doesn't cross x-axis. So no real roots is understood as the graph not cutting x-axis. Two repeated roots is understood as the parabola touching x-axis, or the two distinct and real roots is understood as the parabola cutting x-axis twice. It may be upward if a is greater than 0 and downward if a is less than 0, is already something we have taken as a property in graphical understanding of quadratic polynomials. So this is how we understand the nature of roots connected with the discriminant delta. So let's see one example problem to understand the significance of delta. Find the discriminant of the quadratic equation 2x squared minus 4x plus 3 equal to 0, and hence comment on the nature of its roots is the question out here. So in case of this, we have a quadratic equation 2x squared minus 4x plus 3 whose discriminant, which I need to find, that is delta, and then comment on the nature of the roots of this quadratic equation. So let's see how we can do. Initially, to start with, finding of delta. So the given quadratic equation is 2x squared minus 4x plus 3 equal to 0. Now as I compare this with the general quadratic equation, this is a, this is b, and this is z. Therefore a is 2, b is minus 4, c is 3 is how I get the values of a, b and c. Now once I get a, b and c, then discriminant is given by the formula delta is b squared minus 4ac. We all know that. Now when I substitute the values of a, b, c, I get this as b squared minus 4ac, which on further simplification gives me 16 minus 4 to 8, 3 is 24, which is minus 8. Therefore delta is minus 8, which is less than 0. Now since delta is less than 0, it is the case 3. Delta greater than 0, delta equal to 0, and delta less than 0. Now for case 3, we have seen that delta less than 0 implies the roots are imaginary or complex. Therefore, the quadratic equation 2x squared minus 4x plus 3 equal to 0 has no real roots, because this is with complex or imaginary numbers. It has no real roots. Therefore, you cannot find the solution of this quadratic equation or any quadratic equation whose delta is less than 0. Is how we connect the nature of roots with the discriminant value, the significance of delta.